Traditional control engineering focus on the theory and mathematics of continuous-based control systems. The most common control systems are the open loop and the closed loop feedback control system. The open loop is easy and simple, but requires a trial and error approach. The closed loop control system can handle variation in systems and can compensate for unexpected events. Both of these control systems are widely used in various industrial sectors. In industrial electronics, systems are controlled by control circuits that consist of relays, contactors, and timers, which will affect how the actuator will behave based on the logical condition of the buttons and the switches. However, in recent years, programmable control systems have established themselves to an ever-increasing degree beside relays and contactor control system, static switching system, and process computers. Therefore, conventional control have been replaced by programmable control systems in many industrial sectors. The essential difference between programmable control and traditional control technology is that the functions are no longer determined by the wiring, but rather by the program. Programming is simplified to enable symbols that is familiar to the control engineer to be used in the program. The symbols such as contact symbol or the logic graphic symbols. This is an example of hardwire system. A horizontal transfer module. This is available in GMI, in Pneumatic Lab. So it's a simple system. It's just want to retrieve the blue parts from the chute and place it to the other box. If you look at the wiring, to have that program, this system use hardwire method. You can see there are a lot of relays and there's 3 timers. So the timers and the relays and the sensors and the solenoid valve are connected or are programmed based on the connection of the wires. Example number 2, this example for modern control system using PLC. Okay, as you can see, this is a complex system, a big system. If you look at the wiring, there you cannot see any more timers or relays. All of those devices are now embedded in PLC, so we just use PLC to program the system. As a result of their adaptability and reliability, PLCs are by far the most common control mechanism used by manufacturing businesses of all sizes. The compact physical structure of PLCs significantly reduced the space taken by previous physical components such as relays, contactors, and timers. Instead of building a large mechanical setup of components to control a process, the same components could be drag and drop in a computer interface, saving setup costs and time as well as long-term maintenance. The software language created for PLCs, called ladder logic, retained a very similar look to the wiring diagram that were used for the physical component it replaced. This software design was intentional as it enabled technicians to quickly understand and update the logic as changes were needed with minimal additional training. In addition, ladder logic and other PLC-based programming languages offer a graphical real-time visualization of program and machine operation, unlike most compiled languages. These could aid in system troubleshooting. As a result, control engineers have a platform that is easy to read, easy for maintenance technicians to troubleshoot, and usually allows runtime modification, all with higher reliability than the mechanical analogs.